Here, Student Cluster Competition, SC17, live from Denver. We've got the San Diego State and the Southwestern Oklahoma State University teams. How you guys doing today? And who are you? What do you do?
We are doing very well, enjoying the conference so far. This is my first time attending any of the SC conferences.
Pretty amazing, huh?
My name is Singh Saluja, and I'm from Southwestern Oklahoma State.
Okay.
And rest of the team is from San Diego State University. So we actually collaborated together and working on this project together. So far it's going great. I'm working on the application called Born. I'm the application lead on that.
Okay.
And it was quite challenging, but it's so much fun doing it. So like we were making changes to our system all the time, and like last moment changes after we got the data from the committee. And
are
it's
you running
fun.
Born on the system, or are you doing the cloud?
I am running Born on the cloud.
Okay.
It's more CPU intensive, so we thought like running it on the cloud would be a good idea.
Okay.
And our GPU has a lot of, our cluster is more focused on the GPUs. So other people are utilizing more GPU computational power.
Yeah.
So for the benchmarking, our results were great because we have like 8 GPUs inside it.
Okay. Excellent.
I'll pass it on.
Yes.
Okay. So my name is Chuan Nguyen, and I'm from San Diego State University. My application is Mr. Base. We've been running it on 30 cores about cluster, and it's on CPU, not GPU, because we have been troubling. So at first we have troubling install it with the Beagle library, which is a GPU supported library for Mr. Bay. But then so we got trouble installing it, but then we successfully getting around that issue. But then again, we also had trouble running it with our GPU, so we just scrap up the plan and run it on CPU only.
Okay.
The data set that we were given for Mr. Bay is extremely huge, big. So I can't see that we can finish the application in time. So my plan is just gonna submit the partial result, and we'll see.
Partial credit's better than no credit.
Yeah. It's better than nothing.
Good point.
Hi, my name is Yajish Sharma, and I'm a computer science student from San Diego State University. My application was HPCG.
Okay.
So we ran HPCG on 8 GPUs and received a score of about 750 GFLOPS, maintaining under the power limit.
Okay.
So my max power limit went up to 2.9 kilowatt, so which was just
riding the
edge.
line.
So we were just able to find that sweet spot where we could have the best result, maintaining our power usage under the limit.
Okay.
Power was a big problem for us initially, because a Power 8 system uses a lot of power. The ideal power before using everything was about 2.4 kilowatt, which was painful.
Yes, you had to slim this system down quite a bit. Because I looked at your proposal, and I'm looking at this going, there's no way all these nodes are going to...
So one of the solutions that we decided to do was hardware-wise, we completely unplugged our storage node and just moved all the material into the other nodes.
Yeah.
Another thing we did was we took out the Ethernet box, a 52-port Ethernet box, and we are using a 6-port Ethernet box.
Okay.
A little one like this. So that right there alone saved us about 0.3 kilowatts.
Good.
Another thing was we did some algorithms and to clock up and down the processes and GPUs to maintain our power accordingly.
Good.
So that's how we were able to do the HPCG.
Okay, excellent. How you doing?
Hi, my name's Dane Fairchild. I am the team captain of SDSU, SWOSU, and I'm an electrical engineering major. I worked on the application LIMPAC benchmark. It's a measure of a system's floating point computing power. So it's the main performance metric across any supercomputer that you want to look at. So as far as our data goes, before the competition, I was able to get a score of about 30 teraflops, but that was using the system at full power.
Yeah.
And the power would spike to about 5.2 kilowatts. So, as Jesus talked about before, we had to scale down the power quite a bit.
Yeah.
And I had to sacrifice using one of the compute nodes, which was the one with the 4 NVLink GPUs.
Oh,
So
no.
we only,
You couldn't use the NVLink GPUs?
it would have gone over the power limit for this competition.
Ouch.
So I decided just to go with 2 compute nodes with the latest NVIDIA GPUs, the V100s, and I was able to obtain a score of about 17.24 teraflops. May not be as good as anyone else in the competition, but we did our best working with what we had, and I felt pretty proud about the results that we got.
I was just wondering, I mean, I was looking forward to seeing what it would do with NVLink.
So when I tested it before, as far as the NVLink GPUs go, those were P100s. And the V100s perform better, even as PCIe.
Like quite a bit,
more than the NVLink. Now, I thought the NVLink would work better, but when I tested both configurations, going with 4 V100s and then going with 4 P100s, the V100s won out.
Oh, okay.
Had we gotten V100 NVLink GPUs, I would have gone with that.
Oh, yeah.
And possibly just only gone with one of the nodes.
Yeah.
Instead of the other 2.
Okay. Well, good stuff. Who are the guys behind you there?
Introduce yourself and talk about your. Yes.
Hey.
Hi.
Hey.
Hi. So
you
my
doing?
I'm doing wonderful.
Okay.
My name is Vaughn Ghanamhaka, and as you may or may not be able to see, I'm currently in the progress of writing our reproducibility report.
Ah, yes.
So that essentially requires going over several of the figures and several of the key points in our source paper, which is titled The Vectorization of Tursoff Multi-Body Potential, an exercise in performance portability. And so essentially we're trying to reproduce several of their results and also do a comparison on our architecture here, either comparing via our CPUs or via our GPU architecture.
Okay.
And so it's been a lot of fun. It's been somewhat challenging, but it's been a great experience overall.
It's quite a show here, isn't it?
Oh, most definitely. Yeah, it's a blast. Let me pass the mic off
please.
to Ryan.
How you doing, Brian?
Hi, I'm Ryan Grant.
Ryan,
I'm an electrical engineering major, and I'm in charge of power management and the mystery application, which is MPAS, for this competition. For power management, my teammate Yajish already talked about it a bit, but I wrote a proportionality controller that actually adjusted the core frequencies of the cluster based on our power usage and a desired set point. So that was a big project for me. Then I also wrote some scripts on the side to help us do certain things, and like we could monitor our power usage while you're running applications. So that was a big part of my job. But now I'm focusing all on running the mystery application. We were trying to run it on our cluster. But we have a special architecture, Power 8.
Yep.
And so we weren't able to compile all the necessary components. So now I'm actually working on the cloud right now, and I just finished compiling all the programs that we need. So I'm going to start running some tests on it, see how it goes.
Okay.
So yeah.
Well, thank you guys, and it's great having you here, and we will check in with you again. Thank you.